Hello, it's Scott Manley here, and we are back with Kerbal Spaceships, our serious business, part 17, and our Katie Simmerman he is making a great leap to somewhere higher than there has previously been. No, he's taking the capsule higher than before. This rocket is getting close to what we expect to be a moon-capable rocket. And of course, this is supposed to be the 1950s right now, so we're not really talking about landing on the moon, we're just talking about sending our Katie Simmerman around the moon. On paper, this has the Delta V to do it. However, what we realize is that we don't quite have the technology yet. So, yes, we are out there, we're heading a significant way towards the moon, 191,000 kilometers. However, we are going to lack some basic necessities for such a long trip. Now, of course, we're still working with Mercury capsules, Mercury being the first manned space program from the US, and so we are lacking enough life support to get to the moon. We have some oxygen, we have some food, but I don't think that's going to take us on a voyage to the moon and back. So unfortunately, we are going to have to turn around. I'm not even sure that we can get ourselves through that loop, because that whole time to periaps, it's going to be another 2 weeks basically. Now, the longest Mercury mission was about 34 hours, and that was the last one. It was Gordo Cooper, who, of course, set the record for the longest time in space in a solo American space mission. There you go, for the record books there. They were talking about doing another mission afterwards with Alan Shepard, but they decided, of course, it was time to move on to Gemini. And it's time for me to move on and drop this orbit down a little so I don't die. Time to Apoap, 7 days. I do not think that is a good plan here. So, yeah, just bit of a jink there, you notice, as I realised I was firing my engine back towards the stage behind me. It would have been very embarrassing if I was to hit that thing, wouldn't it? That would have ended my space program a little prematurely, and Arcady is far too smart for that. So that's 10-day orbital period. Let's watch this down. 9 days. I'm thinking this is okay for a week, but honestly, I don't actually know. So 7 days is what we've got. We're going to come back to planet Earth, and hopefully we will not asphyxiate or run out of snacks. I'm not sure what is worse for a Kerbal. But it also means, of course, we're setting a new altitude record, and Arcady has been quite insistent on trying to go higher than anyone else at this point. He also set a speed record. So we get a crew report from this altitude. Brilliant. We'll keep that, and an EVA report. So we just step outside and we'll view the Earth from geostationary altitude. No astronaut has done this in over 43 years or something. I know it's 43 years because I was born just after the end of the Apollo program, and I just turned 43. Yes, I know there's a handful of kids out there that are right now recoiling in horror and unsubscribing as they realize that I'm in fact older than their dads. But whatever. Like, seriously? Oh wait, seriously, electric charge is running out. That could be a problem, because without electric charge, this capsule is not going to do anything, and apparently we're not, our solar panels aren't aligned or something. We should try and adjust our attitude to make sure that we harvest as much sunlight as possible. And maybe shut down the batteries or something. I don't know. Yeah, we are still going upwards, and we need to basically get back to base. So I think, let me just see, we are not actually having a net input of electricity at this point. Yeah, it could be bad if we returned to Kerbin with this whole thing attached to us. I'm actually not sure if Thunder Aerospace's or TAC life support needs electricity in this version. I know it needed it in Interstellar Quest, but you could survive quite a decent amount of time without electricity. But yeah, I don't think this is going to work. We are basically still showing a net draw on the main bus. We have a main bus undervolt. We're gonna have to make some sacrifices. Sacrifices of comfort for the sake of not sacrificing one's life. Maybe we could disable the CO2 scrubber. No, I'm not sure that really works. Yeah. Okay, look, it's new me here. And pretty much what I decided to do was, after a little bit of deliberating, I turned myself around and I started to slow the vehicle down here. So what we're doing is we're dropping the periaps back, and now I'm actually thrusting downwards to take myself back to Kerbin faster, and therefore hopefully reduce the amount of time I have to spend in space, and therefore less time spent in a cold or hot capsule without any lights or any air circulation or anything like that. Air circulation in space is actually really important. It's not unknown, or they've had problems with astronauts that have essentially built up like a cloud of carbon dioxide around their head. Anyway, the Translunar Challenger, we are still getting the power running out warnings. Disabling mech jab, I'm not sure that actually helps either. Really, what I decided to do was rather drastic, but basically go in here and disable electric charge. So we're not consuming electric charge. We've essentially done what Apollo 13 has done, right? Apollo 13, they shut down the power so that they would have battery power left for re-entry. And we need to be able to reorient the spacecraft for re-entry. We need to be able to turn systems on and off. Otherwise, we will almost certainly burn up in the atmosphere. Performing atmospheric re-entry ain't like dust in crops, boy. Without precise calculations, you might burn up in the atmosphere, and that'd end your trip real quick, wouldn't it, eh? Just like a Viking funeral. Okay, so power's off. We have no information, and now we're just gonna... Oh, apparently we're gonna spin like a crazy thing, thanks to persistent rotation. And now we've got 4 hours to periaps. We're coming down pretty close. Well, it looks like we're pretty close to our launch site. Sorry. Power back on. Reorient everything. We do actually have a little bit of fuel here in this. We still have decent fuel, and we should possibly use that for deceleration. Probably more importantly, I should actually drop my periaps a little. I hadn't really been thinking about it. I think maybe 72 might be a little high, given that we're coming in faster than ever before. We want to avoid skipping out of the atmosphere and falling back, because we are really running low on oxygen and food here. Yeah, that might be less than I think, look, oxygen is 20 in the 20s, and the time to periaps is 31. This could be really a turning blue situation. Okay, coming down, 3,000 kilometers, 2,000, 1,000. I hope those instrument engineers fixed the display to make sure it shows reasonable altitudes. Okay, coming in, we're going to be over the Pacific, oh no, we're going to be over the Atlantic. What am I saying? Yeah, we're going to be over the Atlantic, excuse me. In fact, we're going to be on the South Atlantic. Coordinates are actually 13 degrees south by... Yeah, okay, so we're doing pretty well. We're going to fly over Africa. It began in Africa, it ended in Africa. 400... We're just going to watch this. Going to maybe detach that now. Let that float away. And we can use just the little RCS thrusters there using high test peroxide just to shift things away. Again, we do not want to smash into that, because any damage to the heat shield at this stage could be fatal. We have a full load of ablator. In previous tests, we've barely used any of that ablator stock. So I'm hoping, well, I'm expecting that we will seriously dig into our ablator reserves. We will lose a decent amount of that heat shield. But, you know, it shouldn't be any worse than what we've previously seen. Or it shouldn't be significantly worse. If you look at the... Oh, look at that! Whoa, spectacular! It's always very nice to see things burning up like that. While I am safe, protected by the heat shield. I'm wondering how much of that thing will actually survive. Oh, there it goes! And another one! Nice! You would probably feel that if the atmosphere weren't so rarefied. It is looking kind of red here, but we're hardly. Yeah, our ablator stock is. Oh, they're starting to decay now, but we should be fine. We're still at like 90 kilometers here. If that starts getting towards 0, then I will be concerned. But yeah, 80 kilometers and everything. Ooh, it's looking pretty hot there. Come on, burn off your ablator. Instead of... What? Wait a second! That does not compute! How did that happen? Seriously, yeah, Arcady Zimmerman! He went higher and faster than anyone else and burned up. Unfortunately. Spent 7 days and 5 hours in space. And about 5 seconds in the atmosphere before he burned up. I think we should fire that ablator. I mean, okay, the idea is when you fire a ablator that it actually ablates rather than catching fire or something. I don't know. Well, I guess I should be probably doing some tests, right? Well, I'm sure we'll have to have a funeral or something at some point, but right now we still have contracts to fulfill. Gail Porter is the one that has volunteered to, spend a long time in space at a certain altitude and explore the effects of weightlessness on the Kerbal human, whatever you want to call them, body. I don't know if we want to call them humans or if we want to call them Kerbals or if we want to call them something else. Spent a lot of time in space collecting that science. And boy, what science we have. She will know all about spinning around forevermore. And then afterwards, we decided to reuse that upper stage. Because that upper stage, what I did was we have the solar panels on it, well, I just added an antenna. And that way it will become a communication satellite. Meanwhile, we can still use the built-in HTP thrusters to bring ourselves back onto a descent path. And therefore, we get a free satellite, a free communication satellite that should improve our coverage for future missions or something like that. And we also confirm that the lifeboat thruster system, the HTP thrusters, are sufficient to bring us back to Earth safely. Now, given that we can't send manned missions far enough out because I haven't unlocked the labs yet, I'm still waiting for it. I don't know how long it's going to take to build my R&D center. Anyway, because I can't get that, I can't get the advanced capsules, I can't get the life support, I'm going to send more probes out back to the moon. So we're going to try and put a probe on the surface of the moon. And that means a launch which more or less lines up with the moon's orbit. That's where we have to launch from, right? Now, to actually get to the moon, we need to maintain the alignment with the plane, and what I'm using is the rendezvous panel. The rendezvous panel tells us the relative inclination. We want to get that as close to 0 as possible. So all I'm doing is, as I'm ascending, I'm trying to adjust my alignment. Now, of course, you start out orbiting because, of course, you're moving according to the rotation of the Earth. But as we pick up velocity, as we pick up speed, that becomes less and less important, and what's more important is our actual alignment. So now relative inclination is about 4.5 degrees, and we're into our upper stage here. So we used basically the same launcher that we used for Arcady's unfortunate launch. But this is a completely different upper stage here. So we still have that Keralox-based cryogenic stage for getting us into orbit. This burns for a really long time. This takes forever. We end up going into a really high orbit generally. Then after that, we have an AJ-10. So that is a storable propellant motor. That is going to go to the moon, right? And we need the storable propellants because we're going to spend several days in space, and cryogenic oxygen would have boiled off by that time. Finally, we have a Ranger-based landing core, right? So the Ranger probes were spacecraft launched by the US towards the moon, and they were all supposed to crash into the moon. It turned out that they missed, or their rockets blew up 6 times before Ranger 7 actually managed it. But it's one of the first lander cores that you can actually get in the realism overhaul. So I'm using that here. I don't have landing legs, so I'm using these cubic octagonal struts. This may not work. In fact, I'm going to tell you right now, it hadn't worked. Due to an oversight during construction, that green tank is not a pressurized tank. Therefore, the AJ-10 underneath will not work because it requires a pressure-fed tank. It's a pressure-fed engine, which works in 0G. So, yeah, this thing basically gets into orbit and only just... Yeah, we literally run out of liquid oxygen just as we get into orbit. That thing is going to do nothing, so... The best option I came up with to salvage something out of the mission was to turn it into another Earth-orbiting satellite. It has 2 antennae. It will be able to relay signals. It will probably help increase my coverage for, I don't know, low Earth satellites or something. But yeah, we are pretty much abandoning this mission. It's rather unfortunate, but whatever. At least it will have a full complement of scientific instruments for whatever orbit it's available for. And as its engine burns out, the sun rises and it is greeted by a glorious dawn over Earth. We're going to rechristen it the jury-rigged ComSat. Well, after that unfortunate failure, some changes were made. We went back and we optimized things, cut down the weight on the upper stage and added more boosters to the first stage. These boosters are only designed to burn for about 10 seconds. In fact, they add extra mass and make our spacecraft uncontrollable. We only gain control back after we ditch those, and we immediately make a turn towards towards attempting to rendezvous with the moon again. So the upper stage has been optimized as well. We've cut down on some probe parts there, but I think the whole thing actually works a lot better. We also have an extra stage in there. So this is what I'm going to take to the moon. I fixed everything this time. I verified this in a simulation. This whole thing should work. The question is, do I have enough delta V to land it, and can I actually land it with 1.5 seconds of communication delay? Will I have to resort to MechJeb, or will MechJeb itself find itself challenged by this huge delay, this lag in its control input? We all know that can wreak havoc with all sorts of autopilot systems. Anyway, yeah, we're going to space and we will come back to this in the next episode. Until then, I'm Scott Manley. Fly safe.